you can apply value-focused thinking to do capability-based planning. Okay? So here are the benefits of value-focused thinking. Note, number one is what? Support strategic planning. You know, use your strategic values to make your decisions with. Okay, identify decision opportunities. Find hidden objectives. Create better alternatives. Collect information. Facilitate involvement. Very important. So one of the things I have learned in doing a lot of VFT is never ask a group of people that don't have knowledge of a topic for their opinion. You are combining ignorance when you do that. Ask experts for their opinion in their area of expertise. There's a big difference here, right? So if you want to find out about fighter capabilities, you should talk to fighter pilots. If you want to talk about maintenance of fighter aircraft, you should talk to logisticians, right? Everybody see the distinction? Putting them all together and ask them their views does not make any sense and leads to silly things. So, facilitates involvement. Obviously evaluating alternatives, getting better communication. Strip the buzzwords out. Don't use buzzwords. Use verbs and objects. Verbs and objects, not buzzwords. And then ultimately better decisions, and you want to improve your implementation of it. So very important benefits. And I believe these benefits align directly with what's being tried to be accomplished with capability-based planning. Okay, so now we're going to focus on using it directly. Okay, the first some requirements for capability-based planning. We need to do critical thinking about the missions. We don't want to think about the missions we used to do. We need to think about the missions we're going to do in the future. We need critical thinking about alternatives. We need to consider uncertainties. We need to, this may be a new thought for some of you, but it's important to in today's environment where we have model-based engineering, we can integrate our modeling of cost and performance and value
considerando que o emprego de armamento no mundo real é limitado, limitado. Então você precisa ter um sequenciamento correto de qual aeronave.
Okay, that's okay, no problem. Yes. Right. Yeah. The best way to involve experts is involve them in their area of expertise. Not ask them their views on somebody else's area of expertise. We all think we ought to get everybody involved is a good thing. Well, not really. You need to get people involved in their area of expertise. We can talk some more about that. Okay, and then we need to have the best available models and data, and we've got to, having sophisticated output is useless unless the decision makers can understand it. It's useless if they cannot understand it. You've got to convert it to a way that's clear to them at where they are. It's not about you, it's about them when you convey results of a study. Okay, so here is the example we used in the book, Trade-off Analytics, was a small UAV, okay? And I've been involved in UAVs since 1995. when we did a study called Air Force 2025, and we identified UAVs as one of the most important capabilities of the future. So that was back in 1995 using this methodology, VFT. We identified it. And because of the capabilities it provided, right, it enabled you to go from a satellite that only one person could control to having everybody be able to control information, and then also not to put a pilot at risk. So you got to work hard on identifying the functions, and then you work hard on identifying the measures. So, to make this understandable, you should put it in a time sequence. Time sequence. So first we transport it, then we launch it, we survive in flight, we collect data, we recover it, and then we sustain it. See the logic of that? If you see a value-focused thinking model that doesn't have a structure or organization, you know it can be improved. You know it can be improved by putting a logical flow of the capabilities or functions. Does that make sense? So very important to communicate. I can communicate this to any senior leader in any service. Any senior leader in any service will understand this, right? Because I'm talking capabilities, and then I'm talking military measures that they understand, right? So right at the start, I've got the ability to verify with the senior managers that I'm working on the right problem. Do I have the right functions? Do I have the right measures? Okay, then there's uncertainties. They include all these aspects. Now, what I'm going to do is argue, as I have for the last decade or so, on the need for integrated models. And this is an influence diagram. If you've never seen one before, an influence diagram captures the decisions, the uncertainties, and the known information and the values in one chart. It suppresses the details. A decision tree shows you all the details but doesn't show you the big picture. This shows you the big picture. I can communicate this to any senior leader, and I have, because they can look at this and they can understand it, right? So now I've got a value model that people can understand, and I've got a process that they can understand, right? So we've got here the various things we have to do. We start with stakeholder needs. Requirements are a decision. Requirements do not come from God. They're not on stone tablets. They're a decision that we make. And what we're going to argue for in value-focused thinking is you treat decisions not as a single point, but as a continuum over the value curve. So, I'll introduce a value curve, but it works like this. This is the minimum acceptable to the ideal. And then I'm going to say this arbitrarily 0 to 10. Okay? If you remember the first presentation I gave yesterday, when you ask for a requirement as a point, you have no idea what you're getting. None. Are you getting the best case, the ideal, the worst case, whatever the guy's boss or gal's boss wanted? You have no idea what you're getting. So requirements as one point, as a starting point, is a broken process. So what you have to do is get an understanding of the whole range. What's the minimum acceptable? What's the ideal? And what is the trade-off between that? Is it linear? Every increment is equally valuable? Or maybe it's this. You'd like to make an immediate improvement, and then it would tail off, or maybe it's like this. You really got to make a significant improvement before you get the value, and where this is value over here. So we can talk some more about this. Then we can do Monte Carlo simulation over these things. But so the key point here is to treat requirements as a continuum and really get at what's the minimum, what's the ideal, and what's the trade-off. Then we have a trade space that we can use to design. Okay, I'm going to go through this pretty quick. I'm just going to use this chart and I'll skip some of the details. So our goal here is an integrated trade-off that captures the value and it captures the costs, because ultimately it's a cost trade-off for what we need to do. And to do that, we have to have a cost model, and we have to have be able to calculate over usually the whole life cycle. Sometimes we're just interested in acquisition costs, but that's short-sighted. We need to look at the whole logistics tail too. And we need to make decisions about the system models. This is a big problem here. Technology maturity. In the United States, we use TRL, Technology Readiness Level. Okay, does anybody use that here? Okay, TRL is a point estimate, right? So when you ask a R&D person what the TRL is, what do you think you're going to get? What's that? 9, that's right. So in America, we say we have to have TRL 6. So remember cognitive biases. If there's uncertain information, the individual giving you the data is going to do what? Select the number that supports their objectives, right? So friends of mine did a study on TRL, and they found it was systematically biased by 1. Systematically biased by +1. So if you wonder why programs overrun, if you thought you had a TRL 6 or 7, and you really had a 4 or 5, right, that's going to cost you money to fix it. So this is, I mean, these biases come to haunt you here, right? You really got to challenge the TRLs to understand them and put the uncertainty, model the uncertainty. So this is a big deal in defense systems here, big deal. And then we've got models and adversary and everything else. So the key idea is with today's technology, we can put these together in one model using design information and capability models and cost models. Put it all together. Okay, I'm going to skip over these. You'll get the charts, and these just provide explanation of every single one of the nodes, every single one of them, okay? So there's just more detail, but I want to focus on some of the others. And this one, again, TRLs are biased. You got to be careful with that. And the same is true with modeling and simulation. If you go to a modeling and simulation person and their specialty is, I'll pick one, agent-based simulation, right? If you go ask them what model to use, what do you think they're going to say? Agent-based simulation, right? So, I mean, you know, this is pervasive. You have to think through this and make sure you're picking the right model or simulation. Okay. Now, this, and I'm not going to try to go through this in great detail, but here's the idea, and this is due to a former PhD student of mine, Matt Silly, who did this when he worked for the Army. He now works for Johns Hopkins Applied Physics. And we've got up at the top our value model, and down at the bottom are our design decisions. Okay? So what we have to have is we have to have a model that takes the design decisions and converts them to the value measure. Now, for example, if I want the weight of the system, that's an easy one, right? So I can take the weight of every component and add it up. If I want to calculate the endurance of a UAV, I'd have to know engine, wingspan, weight, a few other parameters, and go to the appropriate equation and calculate endurance, right? So, but the bottom line is you have to have a model for combinations of design choices that will convert to these value measures up here. And this is just, it's engineering models. This is what we do, right? We work with engineers and we come up with the best model to do that. And then we can incorporate it in our value model. Okay, so I put this back in here to remind us of the value model that we're going to carry forward with the analysis. So now we get to some math. Now the good news is, to understand this math, you need to know two things. Well, three things. You have to know how to read a function, you have to add, and you have to multiply. Is there anybody here that can't do those three things? Okay, so you are now certified value modelers, right? You can do those three things. This is not rocket science, right? The rocket science was picking the right measures and getting all the models that feed it. This is the easy part, but it's a critical part of rolling it all together. So here's the two equations. We got two equations. And I'm going to take you through this, spend a little bit of time, because this is really the nuts and bolts of how it works. The first is the overall value of the alternative. Okay? That's what we're interested in. What does this alternative value versus another one? Okay? The next thing is these value curves. Remember I mentioned the value curve over here? So we go from the minimum to the ideal. Minimum acceptable to the ideal. Okay? So, and we get the shape of the curve. And I've been able to work with a variety of technologists, hundreds of them, over my career, and operators, and build these curves. It's doable. I once had an economist that told me he couldn't build this curve, and I said, oh, it's linear. He says, oh, no, it's not linear, it's this curve. I said, thank you very much, right? So the assumption that we make is it's linear unless there's a compelling reason for not being linear. Very important thing in doing this is you document the logic for your value curve. Write that down. Why did the stakeholders tell you that this curve had this shape? Very important when it comes to explainability. Okay, then we're going to take a score. Where do we get those scores? We get those from the models and simulations that we used to take the design decisions and convert them to a score, right? And then we convert it to this value via y sub x. Now it's just like y equals f of x, right? Everybody said they know what a function is and how to read it, right? So that's all we're doing. We run that score, we run it through the value curve, and the next step we do is we come to the swing weights, the w sub I. Now, the biggest common mistake here is to call them importance weights. Any technique in multi-criteria decision analysis that uses importance weight is questionable. Any technique that uses importance, you have to use swing weights to be mathematical, and there's mathematical proofs that go beyond addition and subtraction to do that, but you have to consider swing weights, and I'll explain that in a minute. But if you're using importance weights, you're going to make mistakes. So the technique that I've developed over the years, and it's in several books now, is the swing weight method. I'm going to spend a little bit of time explaining it because it's so critical to this. Okay? And then the weights have to sum to 1. So we can assess them initially on a different, whatever scale we want, then we have to normalize them. Okay? So, what have I said we had to have? You had to have 3 things. You had to know how to build, how to read a function, right? Got that? You have to be able to sum things up, and you have to multiply. So, not rocket science. Pretty simple understanding, but extremely powerful. Okay, where do we get the curves? We get the curves by going to the expert for that value measure, right? So if it's a logistics value measure, we go to the logistician. If it's an operational value measure, we go to the operators and ask them, what is the shape of that curve? Because the shape of the curve and the weights are going to give us our trade space to evaluate the alternatives. Now, we can make the curves go 0 to 1, 0 to 10, 0 to 100. I personally never use 0 to 1. If I'm doing advanced technologies, I typically use 0 to 100. If I'm doing closer in things, 0 to 10, right? Okay, and so the requirements here can be thought of as the minimum acceptable, right? And sometimes there's some advocates like to have targets or threshold goals, they call them. And so you can pick your goal and mark it on the curve, what it is. So again, the best practice is to get your experts to tell you the shape of the curve. Now, the key thing here from doing this many times, hundreds and hundreds of times, get the experts to agree on the shape of the curve first, then get the numbers. Because it doesn't do you any good if you have 3 experts. One thinks it's concave, one thinks it's linear, and one thinks it's convex, and you average them out and get linear. You want to talk about what is the shape of the curve. Why is it convex? Why is it concave? Why is it linear, right? So that's important information to know about that capability that you're trying to figure out how important it is. Okay, so they give you the increment of value for every performance measure. Okay, now we come to the swing weight matrix. And this is very hard for people that have never been exposed to it to understand the difference between importance weights and swing weights. Okay, swing weights have 2 components. They have, the first is how important is it to the decision makers and stakeholders, and the second is what is the gap between the minimum acceptable and the ideal. Remember, we're looking for capability gaps, right? Part of CPP, capability gaps. So we may have something that's very important, but we're doing just, all the alternatives do just fine on it. So we don't need to give it any weight. We're going to give that very little weight. So the things that are going to be the highest weighted are right here. They have a high importance to the achievement of that mission or that capability, and there's a gap between the capability we have today and where we want to be. That's what's the most important. Okay? That's what's the most important. And if you do weights without considering these 2 factors, they're going to be wrong. So I give it an example of one of many studies, but this study was done by purportedly very competent analysts. They took it all the way through their organization, and they happened to rate, it would happen to be on ground vehicles to be used in Iraq. And they took it to their first level senior executive, and he said, I don't think reliability should be the highest weighted. And they swore that they asked their experts, and all the experts said reliability was the highest weighted. Okay? They took it to the Department of Defense, and took it to the Joint Staff, and took it to OSD, and presented it, and nobody agreed with their results. Nobody agreed with their results. So the person who was in charge of the original study called me to come out and work with the group to try to salvage the study. All I did with them, was I converted from importance weights to the swing weight matrix, right? And the swing weight matrix put reliability over here and down here. So reliability was pretty important, but we weren't trying to improve the reliability of the ground vehicle. what came up here was soldier safety during the mission. And that's where the gap was and what was mission critical. So we changed the weights around and everything made sense. So, and the other thing is we didn't ask everybody what their views were. We asked everybody's views individually, right? And then we put them together. So this is how it can make a huge difference in your study if you do this right. And this is understandable to senior leaders. They get it. Why is this important to the mission? And this is a capability, a gap I got to improve. So one of the powerful things about this methodology is it's understandable to senior leaders and participants in the study. So it's very powerful. Okay, guess what? This aligns with capability-based planning because we're trying to figure out what's the most important capabilities we need and what's the gap, right, that we have, right? So we're trying to figure that out. Okay, here's the math of this. I'll skip this just to say that you have, that follows this math. The things in the upper left-hand corner have to be better than everything else and all the way down. So there's a consistency when you do the weights. And then what you do is you assess them the following. You pick the most important one, give it a weight of 100, and then you say, or you can start down here and you can give this guy a weight of 1, and then you ask the question, relative to this one, what is the measure worth relative to here? And you do pairwise comparisons until you fill out the matrix. And then when you're done, you just normalize the weights, right? Normalize the weights. Okay, now, what can we do and what kind of analyses can we do with this methodology? And how is it understandable to people? So, we call this a value component chart. And we use color codes to help us here. But we can evaluate a set of alternatives. So here's the ones we used in the textbook, some hypothetical alternatives. And we had the baseline. How was the baseline performing? Pretty poor, right? It only met the minimum requirement in a few areas. So it performed. Now, here's another important point that's missed by many people. What does 0 mean? What does 0 mean? Nope, not no capability. What does 0 mean? The minimum acceptable capability on every measure, okay? That's what a 0 means. So people say, well, it means no capability. And there's some mathematics behind this. You can build models where 0 means no capability, but it's very confusing to people. And so generally we do not do that. We do it with the minimum acceptable. So you just have to explain to people that 0 means minimum acceptable, 100 the ideal. And so we can quickly see that we have the opportunity to make a significant amount of improvement in several value measures. And we can go from the color coding, which I didn't put on this chart, but the color coding will tell you where it is. Now, the ideal, what determines the height of the bars in the ideal? What determines the height of the bars in the ideal? Somebody said it. The swing weights. The swing weights determine it, right? So you can look at the highest value ones by looking at the big bars here. They tell you which ones are the highest value, okay? So we can do that, and that's one. The one that makes the decision, if we're doing deterministic, and we don't recommend only doing deterministic, but if we're doing deterministic, this is the chart that senior leaders want to see. This is, we call this a Pareto chart, right? This shows life cycle cost on the x-axis and value on the y-axis. Okay, now, how do we interpret this chart? Okay, does everybody know what I mean by a Pareto chart? How many know what a Pareto chart is? Okay, maybe half the thing. So a Pareto chart is going to be done by the following. So would you rather have attack or sustainable? Which would you rather have? Okay, why? Say it again. Yeah, its life cycle cost is more and it provides less value. So this attack dominates sustainable. Long range dominates survivable. Okay? So we can see that some of the alternatives are dominated. Does that make sense? So those would be the ones that we probably aren't going to consider, right? Unless this probabilistic analysis tells us otherwise. And that's what we mean by a Pareto chart. We identify the non-dominated alternatives across the gap. So this is a common chart that we like to use in defense planning. Pick the best bang for the buck, right? So we do that. Okay, now we come to uncertainty modeling. So over here we said we sometimes aren't going to be certain of our scores. We're going to use modeling and simulation, but maybe we're using a probabilistic model that's going to tell us that the scores could range from X to 2X, say, right? So instead of ignoring that and picking the mean, now we're going to put a distribution on those scores. And how many know what Monte Carlo simulation is? Raise your hand if you know what Monte Carlo is. So roughly half of you. So if you've never heard it, you should look into it. You can convert any deterministic model, any model, to a probabilistic model with Monte Carlo simulation. Okay? You can take any spreadsheet model or any other model and put distributions on it. Now, there is a software that does this that's available. There's two versions that are very popular. At Risk, Crystal Ball, there may be others that you have access to. There's also software that's free under a website called Probability Management that you can download and use in your Excel file. So there's a variety of ways of doing it, and then you can, of course, write code yourself to convert any probabilistic or deterministic to probabilistic. So we are going to put distributions on the inputs, right? And when we can put distribution on the weights too if we want. If we're uncertain what the range is, we can put distribution on those. But primarily we put distributions on the scores. And when we do that, because we have an integrated model, right, that we're going to propagate that uncertainty through both the cost model, the performance model, and the value model all at once. Because they're integrated, right? We put a distribution on a capability. It's going to run through, that distribution is going to run through the value model, it's going to run through the cost model. Okay? So, you know, there's logistics cost to being less reliable, right? So if the reliability is low, we factor that into our life cycle cost model, right? If the availability is lower, we factor that into our life cycle cost model, right? And if the performance is higher or lower, we factor that in the performance. But we're doing it all at once, simultaneously, so we got consistent data. The beauty of these is anytime your data changes, you don't restart your analysis. All you do is update it. All you do is update it. And you're ready to go. You don't do the model, throw it out. You do the models and you keep them all the way through the program and improve them and develop them and use them through the program. Okay? And so that's what we can have. So we can have distributions on value. We can have tornado diagrams. I'll show you those. We can have distributions on cost. Okay? So here is one of the distributions that we can do. This is, before we said attack was better than sustainable. Well, it looks like even if we consider uncertainty that that's true, right? That even considering uncertainty, it is still true. But up here we can see maybe a little bit more overlap here, right? And that survivable, when we looked at uncertainty, it actually, its mean was higher here. And so we can look at this, and this is usually the case. The better they are, the more high technology they have, they're going to be have more uncertainty, right? The lower the capability, the more they're using existing things, there's less uncertainty, right? So this is a characteristic. The high value things are typically going to have more uncertainty in them. Okay, this one is pretty understandable to show to a senior executive. This one's a little bit harder. They got to understand how to read a probability distribution. In this case, it's a cumulative distribution. And the way we read a cumulative distribution is we look for alternatives that are down and to the right. So the higher they are in value, the better they are. And we talked about dominance deterministically. This is stochastic dominance. So we can look at this and we can see that here attack does dominate sustainable, right, in terms of value, very clearly. But here these two overlap, right? There's no one alternative that dominates. But this guy here, these two, except for down here, this small percentage, performance outperforms the other one, the previous one. So we can analyze this through the power of building integrated models with Monte Carlo simulation. Okay? How much time do we have? 10 minutes. Good, great, thank you. Okay, so here is the what we call a tornado chart, and it shows the impact of the uncertainties on the alternatives. And so here, the largest uncertainty is caused by this one, but the largest cost uncertainty is caused by this one here. So it's called a tornado diagram just because the shape looks like a tornado. And so we're able to see which factors have the biggest impact in value by looking at this. Okay, so what I want to do is summarize and then open it up to questions, because I'm sure you'll have some questions about this. So we talked about post-Cold War strategy and how it tried to go to multiple regional conflicts, but that created problems. You had to specify the conflict, get scenario data, a whole bunch of stuff. And that changed to capabilities-based planning. It's got a lot of challenges. It's not meant for alternative-focused thinking and a bureaucracy that isn't creative. It's meant for creative thinking about what are the most important missions that we need to have capabilities, and then how can we creatively create those capabilities. And we showed that, hopefully convinced you, that value-focused thinking is a very natural fit with capabilities-based planning. Ralph wouldn't know what capabilities-based planning was, right? He doesn't have expertise in defense. But it turns out that it does have a great deal of applicability to it. And then we talked about the importance of having frameworks that you can explain to senior leaders and stakeholders and get their understanding and buy-in. And those frameworks they begin with the value model. What functions are we trying to achieve, and how do we measure them? Every senior leader wants to know that. There's no sense starting with the modeling and all the details if you haven't got buy-in there, right? So that's critical, and it's understandable to them, if you put them in time order sequence. If you give somebody a random just list of functions and measures, it's hard for them to understand. But you put it in that logical sequence and they can get it, because they think in that way. That's how military folks are, right? We think logically in terms of the steps we have to take on any mission, right? So if we put them in that, we're all set. And then I argued for integrated analysis. Okay, my kids and grandkids, especially my grandkids, are born digital. They have no interest in paper. My students have no interest in paper. They are interested in models and tools that are digital, right? So the time for paper is long gone. And the only people that use paper are dinosaurs, right? So we need to move beyond paper and move into the digital world here, where paper is outdated the day you print it. The day you print your trade study in paper, it's outdated. We want digital trade studies that can be updated with every test result that comes in, every change in requirements, every change in capabilities, right? We want to update that and have a quick understanding. The sooner we can find out the cost impact and performance impact of a change, the higher probability we have of compensating for that change without large costs. Okay, so it's very important to do that and have these models update. Okay, so that I argued for that. And then finally here, to show the cost versus value, either deterministic or probabilistically, to show the relationship, because that's what they're really interested in, is what's the impact? If I spend this much money, what's the projected impact in value and performance? And the power of this method is you can trace it back to, so if somebody challenges, well, why is this guy better than this one? Okay, well, we go to the value model. Let's look at the scores in the value model. And we start seeing right away why one performs better than another, right? And then you can go to the value curve and say, do you agree with the value curve? Because I've had senior leaders tell me, this is absolutely wrong, makes no sense. And I take them through the details, and then they come up, oh yeah, I see why this is. It's because the value, I was thinking it was linear, and it's not linear. It's convex, right? So then they say, yeah, that makes sense, right? So you have an explainability component here that you don't have in other techniques. Because you can boil it down. You can say, well, where did you get those scores? Well, here's the model and simulation, here's the data was run, right? And so we got complete traceability to defend our answers. Okay, let me stop here and try to answer some questions in the time we have remaining. I'm sure there's quite, you must be hungry for lunch. Yes, sir.
Colonel, excuse me, thank you for this great time with us. It's a great pleasure for us first. So, in your opinion, what is your final advice for us? I mean, you gave us many of information that I think the most of us, like me, never thought about. So, right. What is, in your opinion, the best way to start with or to put it all together in practice in our areas of knowledge or working or studying?
Sure, that's a great question. And I think one of the key things I would start with is start with the qualitative value model. Start with that. Start with talking to your team and think about what are the capabilities you have to have and how are we going to measure that. And because that drives everything, right? Once you know those metrics and measures you need to measure, then you can go to the modeling and simulation guys and say, how do I get data on this for this kind of capability? But it starts there. And then you need to have on your team people that have the capabilities to do all the components of this work, right? So they have to be able to understand modeling and simulation. They have to be able to understand Monte Carlo simulation to have the full benefit of this. And then the other one, and it takes practice to do, is building the value curves. It's very challenging for people to build value curves. So I start them with buying a car, right? And I start them with miles per gallon. And I ask, what curve would you want? Most people say linear. Although some people, they would have different requirements. Some people would say, I wouldn't buy a car that doesn't have 35 miles per gallon, right? Others would say, no, I want a bigger vehicle. I'll take 20 miles. You know, but those are the kind of things you have to do. So you take them through things like that, then you take safety ratings, and you ask them to build a value curve for that. So you build a value curve on something they can understand first and have a lot of familiar, and then you start going to the real value curves. But it takes practice. But with a little practice, it works. And people will, with a little practice, they'll start saying things like, oh, it's linear. Oh, it's concave. It's convex, right? Once you've introduced them to those concepts. And then you know you've got them and they understand it. But you got to make sure that with a toy problem that they understand the concepts before you go to the real project. Yes.
Hi, Dr. Parnell.
Yes.
It's quite common for us to see people getting confused with different concepts like force sizing, strategic planning, capabilities-based planning, and VFT, AFT. And do you have any suggestion on how to avoid it? So specifically talking about the Brazilian Air Force, now, we are struggling to discriminate what is capability-based planning and strategic planning and force sizing.
Right.
What would you suggest to us to avoid this bias and confusion?
Right. Well, you know, I guess I would probably start with some definitions and examples, right? And especially with pictures. People get it quicker with pictures, right? Because what we did here is look at the individual capability of the UAV. I could build a value model that talked about a fleet of UAVs, right? And that would be force sizing. So the question is, we'd have different measures, right? And would it require more modeling and simulation? Because it'd have to, and if you know, if it was a mission over time, I'd have to refuel, I'd have to restage, and we'd have to model the availability and reliability, and et cetera, right? But we could do that. So I would try clear definitions and then examples. Would be the key. People grasp examples better. And this is why capabilities-based planning was so hard in DOD, was because everybody had an idea of what they thought capability-based planning was, and it wasn't Paul Davis's idea, right? It was their idea, and they were trying to force fit their services programs into this new process, as opposed to really start and understand the process, and then look at it.
Good afternoon, Professor. Thanks for a great presentation and explanation on the very different concepts and models and analysis of this. We have been grateful to receive this kind of analysis and to get what we need and what we intend to do, which is trade-off analysis, analytics and analysis. I would ask you if U.S. succeed on capabilities plan. Have you succeeded on this task, this major task, doing this?
Have I succeeded on the task?
No, U.S. government, DOD, has succeeded.
There are groups of people and studies that have been done very well in this area. And I told you about the study that had to do with the ground combat vehicle. That one succeeded after they solved the problem of the weights. That was a successful study. I know various colleagues of mine that have done this have told me about the successes they've had. The author of this chapter that I used here is a Army colonel, just retired, and he used it very successfully. Matt Chile used it for the Army, and now he's working on Navy programs. So there's lots of pockets of this being done.
But in
successfully.
order, let me complete the question. But in order to measure the whole U.S. force, the whole DoD, applying capabilities-based planning, did you manage to do this for the whole DoD or just?
No, that would require having capability-based planning is essentially breaking down the capabilities and look at each one of them. And then if you take the way it's aggregate, there's no aggregation of it, right? Except taking these studies and then aggregating them together and doing an overall assessment. But basically, you would look at mission area by mission area. Thank you. Any other questions? I think everybody's ready for lunch.
Dr. Parnell, on behalf of the Brazilian Air Force, I would like to thank you, firstly, for flying all the way down to Brazil. We do know that you have a lot of things going on back in the U.S., and you took your time to share your expertise and your experience and your knowledge with us, and it is invaluable. So thank you so much for everything. That's an honor for us, and we are looking forward for further cooperation and integration with you, sir. Okay. Thank you so much.
Great.
Let's have some lunch.